Alright, so today's lesson is going to be about finding the critical points. So the critical points is when you have a maximum minimum value problem and you have some function that's like that. So where you're going to have your tangents at those very maximum or minimum points, these points along here are going to be your critical points. Okay, so simply we're going to do a problem where we have some function of time, so t to the power of 3 over 4 minus 2t to the power 1/4. So as in the last video, to find the critical points, you need to determine when the maximum and minimum values are occurring. In other words, when the derivative of our function is equal to 0. So first off, we need to find the derivative of this function. So we're going to take f prime of t. We're going to do our similar derivative rules that we always had before. And I'll write these out so you can see what I'm actually doing. Okay, so next you're just going to simplify this a little bit. But what we're going to do here is we're going to keep our factors out in front in terms of a denominator of 4, because that's going to make it easier for us to simplify. Okay, so what's going to happen now is we can pull that 1/4 out front, and we're now left with 3t to the power negative 1/4 minus 2t to the power negative 3 over 4. Okay, so what we're going to do now is that we're going to factor out t to the negative 3 over 4 to allow us to simplify this a bit more. So it's going to make it a little bit easier for us. And if I write out what I'm doing here, I'm taking away a negative. So that's what's going to happen. Minus 2. Because that there was being pulled outside. So what this is going to leave us with is 3t to the power 1/2, or 3t square rooted, minus 2. Alright, and since we know what we're doing is that we're setting this whole thing equal to 0, so now let's solve for what t's are going to allow this to equal 0. So first things first, let's rewrite this in terms of actual numerator and denominator, or quotient. Makes it a little bit easier to follow here. And simply enough, you bring this up here, you're multiplying that by 0, it's just going to give you 0. So you're left with 3t to the power 1/2 minus 2 equals 0. It's going to give you 3t to the power 1/2 equal to 2. It's going to give you t to the power 1/2 equals 2 over 3. So t is going to equal the square of that, which is going to equal 4 over 9. So that right there is the critical point where our derivative is equal to 0, and the other critical point we're going to have, if you look at what we have, is going to be when t is equal to 0. And the reason for this is, if you look at what we have, you have a t in our denominator, and you can never have a denominator equal to 0. So therefore, the derivative here isn't able to exist. And remember, by our definition in the last video, one of the critical points is when either the derivative is equal to 0, which creates a flat tangent, or when the derivative does not exist. Therefore, t equal to 4 over 9 and 0 are critical points.